Welcome to this video on coding theory. In this video, we will explore the fascinating world of coding theory, which is a branch of mathematics that deals with the study of error-correcting codes. Coding theory has numerous applications in various fields, including computer science, telecommunications, and cryptography. Coding theory is all about transmitting information over a noisy channel. When we send information over a channel, there is always a chance that the information will get corrupted due to noise or interference. This is where coding theory comes in. It provides us with techniques to encode the information in such a way that it can be transmitted over a noisy channel and still be decoded correctly at the other end. The first question that comes to mind is, what is an error-correcting code? An error-correcting code is a code that is designed to detect and correct errors that occur during transmission. It does this by adding redundancy to the original message. The redundancy allows the receiver to detect and correct errors that occur during transmission. There are two types of error-correcting codes: block codes and convolutional codes. Block codes divide the message into blocks of fixed length and add redundancy to each block. Convolutional codes, on the other hand, add redundancy to the entire message rather than to individual blocks. Coding theory has numerous applications in various fields. In computer science, coding theory is used to design error-correcting codes for storage devices, such as hard drives and flash drives. In telecommunications, coding theory is used to design error-correcting codes for wireless communication systems, such as Wi-Fi and cellular networks. In cryptography, coding theory is used to design secure communication systems that are resistant to eavesdropping and other attacks. In the next segment, we will explore the different types of error-correcting codes in more detail. In this segment, we will explore the different types of error-correcting codes in more detail. Block codes are the simplest type of error-correcting codes. They divide the message into blocks of fixed length and add redundancy to each block. The most common type of block code is the Hamming code, which adds parity bits to the message to detect and correct errors. Convolutional codes are more complex than block codes. They add redundancy to the entire message rather than to individual blocks. Convolutional codes are used in applications where the data is transmitted continuously, such as in wireless communication systems. The most common type of convolutional code is the byte-to-byte code, which uses a decoding algorithm to correct errors. Reed-Solomon codes. Reed-Solomon codes are a type of block code that is widely used in storage devices, such as hard drives and flash drives. They are also used in digital communication systems, such as satellite communication systems. Reed-Solomon codes add redundancy to the message by encoding it as a polynomial. The polynomial is then evaluated at specific points to generate the redundant data. Turbo codes are a type of convolutional code that was developed in the 1990s. They are used in applications where high data rates are required, such as in satellite communication systems and mobile communication systems. Turbo codes use two or more convolutional codes in parallel to add redundancy to the message. LDPC codes, or low-density parity check codes, are a type of block code that is widely used in modern communication systems, such as Wi-Fi and cellular networks. LDPC codes are based on a sparse matrix, which makes them efficient to decode. They are also highly resistant to noise and interference. In the next segment, we will explore the applications of coding theory in more detail. In this segment, we will explore the applications of coding theory in more detail. Coding theory is widely used in storage devices, such as hard drives and flash drives. Error-correcting codes, such as Reed-Solomon codes, are used to detect and correct errors that occur during storage and retrieval of data. Without error-correcting codes, data stored on these devices would be vulnerable to corruption and loss. Coding theory is also used in wireless communication systems, such as Wi-Fi and cellular networks. Error-correcting codes, such as LDPC codes and turbo codes, are used to ensure that data is transmitted correctly over the wireless channel. Without error-correcting codes, wireless communication systems would be vulnerable to noise and interference, which would result in dropped calls and slow data rates. Coding theory is also used in satellite communication systems. Error-correcting codes, such as turbo codes and Reed-Solomon codes, are used to ensure that data is transmitted correctly over the satellite link. Without error-correcting codes, satellite communication systems would be vulnerable to noise and interference, which would result in poor signal quality and dropped connections. Coding theory is also used in cryptography, which is the science of secure communication. Error-correcting codes, such as Reed-Solomon codes, are used to ensure that data is transmitted securely over the communication channel. Cryptography also uses other techniques, such as encryption and digital signatures, to ensure that data is protected from eavesdropping and other attacks. In conclusion, coding theory is a fascinating branch of mathematics that has numerous applications in various fields, including computer science, telecommunications, and cryptography. Error-correcting codes, such as block codes and convolutional codes, are used to ensure that data is transmitted correctly over noisy channels. Without coding theory, many of the technologies that we rely on today would not be possible.